So here we go. So this is a problem for our final exam. So it says simplify and state any excluded values. So simplifying means add, subtract, multiply, or divide. This one's division. So we have to be able to divide out exact factors. So you guys were awesome. The first step is to do what to it? Factor it. So we factor out the top. And what did you do first when you factored out the top? Talk me through this. Pulled out a 3, divide by 3, divide by 3, divide by 3. What was left? Okay, thank you. And then does that factor further? It's a quadratic. Does it factor further? Well, multiplies to be -4, a times c, and adds up to be -3. 1 times 4, which one's negative? Good, can we quick factor it? That's a 1 because we pulled out a 3, so we can quick factor it. So now I'm not going to draw that line. We have a 3, and then this piece factor to be x plus 1, x minus 4. Very good. Now focusing on bottom, you say what multiplies to be 24, a times c, and adds up to be -10. 6 times 4, both need to be negative. What if we use factors 2 times 10? Then that doesn't work because, right, let's think about it. I mean 12, sorry. I saw a few people start out, right? And then they use this. But, they use this. But that doesn't work here, right? -12 times +2 isn't +24. So the bottom factors to be, quick factoring is okay, right? 1, gotta check that, x minus 4 and x minus 6. So then from there, we would exclude our values first, which most of you did. So x cannot be, you can't divide by 0. Uh-oh. Okay, we can't divide by 0, so x cannot be 4 and x cannot be 6. Very good. Divide out exact factors. So 3x plus 1 is left on top, and on bottom x minus 6. And then there's our exclusions. So in our domain, the only x values that don't exist are 4 and 6, right? Any other number works. Okay, good. All right. Any questions on that? Okay, so what we're going to do, the first little bit of class, is we're going to review some things and work as groups. So, first thing I want you to do is, remember that shifting through all functions from a parent function works the same. I want you to discuss as a group in example 1 and example 2. Is it or is it not a shift from the parent function? Yes or no? If so, what is the parent function? So if you say yes, what's the parent function that it was shifted from? And then describe the shift in words. Everybody go. You should be talking as a group. Okay, so everybody, is this a shift from the parent function? No! This group got it back here. N-O spells heck no. Why?
What?
It doesn't really spell heck no, but in math it does, because this is a big no. Okay. Why is it no? There can't be 2 x's in a shift from the parent function. We've talked about that a lot, right? A few times. If there's 2 x's, it's not a shift from the parent function. Okay, so this one is a shift from the parent function. What would my parent function be? Good, square root of x. Now describe in words the shift. What's that shift? Right 2, up 3, stretch 3, reflection over the x-axis. Very good. Okay, so remember that, guys, not a shift from the parent function if there's 2 x's. So once again, is this a shift from the parent function? No, 2 x's. Okay, cool. All right, now I want you to go as a group, erase your whiteboards. Put your flags down. I want you to write the equation of the given shifted functions. So first you'll see what the parent function is, and then say the domain and range. You should all write it down. And when you all agree, put your flag. All right, so tell me, how about this group? You know what? I'm going to say to you guys because I saw your guys' answer that was correct for the second one first. So over here, let's go with you back there. That group, group 6. What did you say the parent function is for this? Square root of x. How many agree? Raise your hand. That is true. Okay, very good. What was the shift? Write out what's the new function? Minus 3. How many got that exact same answer? Raise your hand. Okay. Okay, Okay, so that was left 6, down 3. Should left and right go opposite? That is true. So this needs to be plus 6 and then minus 3. So group 1, do you see where you made your error if you didn't have that already? Or where's your error? What's different? Oh, you had that. Okay, raise your hand. Participate, because then I think you didn't get it. Okay, the domain. Let's go with middle group back here. 5. What's my domain for this? How many agree? Raise your hand if your group agrees. That is correct. Okay, what's the range same group? -3 to negative infinity, and we'll write the smallest one first. So negative infinity up to -3. Very good, very good. How many agree? Good. Awesome. Okay, how about you guys? I saw some good things over here. So what equation is the parent function of this? Good. Cubed, x cubed. So what was your new equation? Oh, you said negative? X plus 4 cubed plus 2. Okay. How many have that exact same equation? Raise your hands big. Okay, not you guys. So what do you have that's different? Okay, good. So that's a good mistake to make now, because remember that normally this would be increasing. Normally it's over 1 up 1, but do you see how it's over 1 down 1 now? So it is a reflection. That's a common one to miss. So that's why we're here. Okay, so domain. Let's go with group 1 right up here. What's my domain for this one? Where's the function going from left to right? Yep, my domain is all real numbers, negative infinity to positive infinity. What's my range? Also all real numbers. Okay, how many agree? Okay, good. Next thing you're going to do, erase your whiteboards. What I want you to do, put your flags down. Write the equation of this piecewise function. So a couple things to notice. There is 1, 2, 3, 4 different functions. So you should have 4 different equations. Focus on it in pieces. Look at the blue function and say, what kind of function? Let's write that equation. Does that make sense? Then you keep that over this interval. So once again, you can do it. Ready, go. All right, guys, if you don't have these by now, then you don't understand it enough. We gotta go over it. But couple things, we can't let it psych us out, because just because there's a bunch of pieces in here doesn't mean we can't actually write an equation. I just saw you write a bunch of equations for all of these, for the most part. So let's focus in on, let's go from left to right first of all. So I'm writing f of x is equal to, from left to right, this first blue function is what kind of function? X squared. Very good. It was shifted. It was shifted left 6. Guys, look at it. So how do you go? It's x plus 6 squared. Guess what I saw people do? X squared plus 6. Isn't that a shift up and down? Yikes. We know better. We know better. So that's x, and there was no shift up and down. So isn't that my function? That's it. And then it's still over 1 up 1. So we would write my first function is x plus 6 squared. Now that's our function between these x values, right? Look. Between -7 and 4. So you'll go -7 and -4. X is between those, right? Now does it include, so is this quadratic included at -7? Go to -7, go up to the quadratic. Is it included? -7. No, it's an open circle, guys. So that doesn't mean we get to include it. What about at -4? Go to -4, go up to the function. Is it closed off? On the quadratic, yes. So we would close it off. Moving on. This is a line. I only saw one group, maybe 2 groups get this right. Guys, this is a straight line. What's my y-intercept? So it's a line. Okay, x is the thing here. Now, it shifted up 2, correct? So plus 2. Now, is there a slope? So there's 0x. So no, that's not x plus 2. It's just, no, just 2. It's a straight line of 2, guys, with 0 slope, right? This group got it. What other group got it? I thought, oh yeah, I was going to say x squared, 2 groups got it. 2 is my function. Do you guys understand that a straight line like this with no slope is just 2? Okay. For x values between -4 and 1. So go like this, -4, 1, x is between. It's less than, okay, here we go. So at -4 is our line included. No? Okay, and then at 1, is it included here? So we close that off. Moving on. This is another line. It has a negative slope of down 1 over 1, down 1 over 1, right? If it continued up, wouldn't it cross here at 5? So plus 5, negative x plus 5, right? Does everybody see why?
Yes.
But then it's from 1 to 4. So 1, 4, x is between. So x is greater than 1, for x value is greater than 1, but less than or equal to 4. Look below 4, including 4. And then that brings me to this, which those of you, by the way, that did this as an absolute value function, it would not be marked wrong if you did it correctly. So if you called this an absolute value function that was shifted right 4 up 1, then that would also be considered correct for this. Because I saw this group do it, I just don't know if your shifts were wrong. Does that make sense? Okay. So then from here, this is a what kind of function? Square root, guys. And isn't it reflected? And isn't it shifted right 4 down 2? So that's negative square root of x minus 4 minus 2. And that's for all x values greater than 4, right? Not including 4. For x values greater than 4. Does everybody understand? No questions? We can do it on the test. Okay, good. All right. So if I said to you, what's the function? What is the function at 0? You would just look at this and say 2. How else could we have done that? We would look here and say, which interval should I plug that into? 0. Isn't that this x value on this interval? So then we know it's 2 because there's nothing to plug in. Does everybody get it? Okay, cool. Moving on. Once again, that was the hardest lesson in secondary 2, and it just became one of the easiest in secondary 3. So look and see how far you've come. It's pretty cool. All right, awesome. Here we go. We're going to teach you 7-3 today. This is a huge lesson. You're going to see it in pre-calculus, which most of you said you're going to want to go on to next year. So this is a big day. So today, like I said, is a huge day. You're going to see this a ton, and I expect you to be really good at it. So inverse relations and functions. We're going to be taking a function and finding the inverse of the function, which you'll know what that means in a second. So first of all, we need to get to some notation, which notation just means how something is written. So if we have original function f of x, this is how you write find the inverse of the function. This f negative 1 of x. Do you see the difference? This is how you denote or write that I want you to find the inverse, or I did find the inverse, that negative 1. So if you have a function y, to write how find the inverse, or to write I did find the inverse, you would write y negative 1. So inverse is written with like a negative 1. That just means inverse of the function. So one thing to note is a function's inverse, if you have an original function, the inverse is going to be taking that function and reflecting it over the y equals x axis. So notice I drew in y equals x here, that blue dotted line here. So think about why this line is, what this line is, just so you can do it yourself. Y equals x, isn't that a line with 0 y-intercept? Isn't that 1x plus 0, guys? So that means we start at 0, and then our slope's 1. So you start to go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, down 1 over 1. Y equals x. Okay, so I'll say that again. A function's inverse is taking the function and reflecting it over the y equals x axis. Okay, perfect. So, to find the inverse of a relation, what a relation is it's not a function necessarily, it's not connected, it's just a bunch of random points. So to find the inverse of a relation or a set of points, we simply switch x and y. So if I gave you an xy point, to find the inverse, all you have to do is literally take and switch x and y. Okay? So what I want you to do is go to your pink worksheet and look at number 1. Given this relation, this set of xy points, I am going to have us find the inverse. So write it as xy negative 1 so that we know that this is the inverse. We're on the pink worksheet. We're all doing this together. Did you all hear that? Number 1. So we switch x and y. So negative 4, negative 3 becomes negative 3, negative 4. Negative 3, 1 becomes 1, negative 3. 1, 2 becomes 2, 1. We're just switching x and y. 4, 3. So how do I find the inverse of a point? Switch x and y. That's all you got to do. So what I want us to do is graph those on an XY chart. So everybody should have picked up an XY chart when you walked in over at the door. Label it number 1. We're going to graph those points. So what we're going to do first is graph our original function. Here we go. So graph those points. We're going -4, -3. Plot those points. Graphing the original function, -3 up 1. We're just plotting both the function and its inverse. You all understand what we're doing? Okay, go. 1 over 1 up 2, over 3 up 4. So I graphed the original function in green. And now I'm going to graph also the inverse function in pink. So now I'm graphing those points. You are too. So -3, -4, over 1, -3, over 2 up 1, and over 4 up 3. Okay, yeah, perfect. So now also draw in this dotted line. It's not really there. I just like to have it in there because that's what we know. A function's inverse will be a stamp over that dotted line, a reflection. So look, you see how if I took those green points and went like this and folded it and stamped it across, it would be a reflection over that? That's what an inverse will always look like. It's a reflection over that line. Always that exact line. So look, even distance, even distance, even distance, and even distance. So it makes sense. Okay, so we've learned so far that inverse function is a reflection over the y equals x axis, and to find the inverse of a set of points, you just switch x and y. Okay, what I want you to do is do 1 through 4 on your white worksheet. You're going to graph them on your graphing paper and label. So you'll just write number 2 on the pink. And then do 1 through 4 on the white. Ready, go. I'm going to make a connection. So what I want you to know is looking at these two functions here, the red one, look at the notation, is the original function, right? And the green one would be the inverse. So looking at these, let's see if this does make sense. We know that these points will be reflected, right, over the y equals x axis. So that is the inverse of that, right? Everybody? And then that is the inverse of that. That's the inverse of that. So do you see, Luis, how that was on the y equals x axis, so it just stayed on there? The reflection? Good. All right, so let's look at the red function, guys. With me, tell me what is the domain of the red function. So what is the domain? 1 to infinity. Okay, good. 1 to infinity. And what is the range of the original function? 3 to infinity. Okay, any questions on that? Okay, let's look at the green, the inverse function. What's my domain? Domain 3 to infinity. Good. 3 to infinity. And my range is 1 to infinity. What do you notice about the domain and range of the original function and the inverse function? They flip-flop, right? So that is true. It's always going to be true. The domain on my original function will be the range on my inverse. You see how they're the same? My range on my original will be my domain on my inverse, and so on. So once you know this is domain and range, you know this one's domain and range. Does that make sense, everybody? Or if you know the domain on this one and the domain on this one, you know this one's range and this one's range. Does that make sense? This one's range. Does that make sense, everybody? Okay. Cool. So I just want to clarify everything we've learned so far about inverses. So everybody listen. 1, a function's inverse is a reflection over the y equals x axis. Check to that. 2, to find an inverse of a point or a set of points, you simply switch x and y, right? So 3, 2, the inverse would be 2, 3. And then third, the domain of that function is the range of the inverse. And the domain of the inverse is the range of the original, right? Okay, I'm going to sneeze just a second. Thanks. Maybe not. Okay. All right. Now, one thing to note, not all functions are inverses. Sorry, what did I just say? I'm thinking about my sneeze still. Sorry. Not all functions' inverses are still a function. So look with me at this quadratic. I have a bunch of xy points here, so this is inverse would be 6, negative 1, right? 3, 0, 2, 1, 3, 2, 6, 3. So watch me graph this, which we know it's a reflection over that line, right? Watch me graph this. Over 6, negative 1, over 3, up 0, over 2, up 1, over 3, up 2, over 6, up 3. So I graph this. Okay. Do you see how now the inverse is not a function? Now it's not a function because a function passes the vertical line test, meaning my pencil when holding one x spot will never have two y values. Do you see how at 3 we have y values, two y values? And so on all the way over, we have two y values. So this is the true inverse, but it is not a function, which happens. So that's a question they'll ask you. They'll say, find the inverse, is the inverse a function? So won't all quadratics that have an inverse be a reflection like this, and then it's going to be no, right, everybody? Okay, so a quadratic's inverse will be no. What I want you to notice is this is a quadratic that's been shifted right 1 up 2, right? X minus 1 squared plus 2. Now, isn't this technically, if we erased this bottom half, isn't it a square root function? That's been shifted right 2 up 1, right? Square root of x right here, if we're just graphing the top half, it would be right 2, so x minus 2 plus 1. Do you see how they look kind of similar? It's just notice this has a top half and a bottom half. So that's both the positive root and the negative root. If I put just the negative root, wouldn't that just be the bottom half? Everybody, a reflection? Do you see how that's working? Okay. All right, now this is my favorite part. Here we go, back to the worksheet. So back to the pink worksheet. These are the steps you're going to want to write down. This is the hardcore cool stuff. This is the fun stuff. This is the algebra. So now instead of finding an inverse of a set of points or finding an inverse of a graph, we're going to find the inverse of an equation. Here are the step-by-step instructions. If you follow these steps, you'll be able to find any inverse I give you. So first, what you're going to do is given an equation to find the inverse, just like we did with our x and y points. First thing you're going to do is switch x and y in the equation. So wherever there's an x, you'll put a y. Wherever there's a y, you'll put an x. That's our first step. You're going to want to write these down. Second, then once you've switched x and y, you're going to get y all by itself using algebra. So we're going to get it back into the form y equals an equation. So we have to get y alone using algebra. We want it in y equals an equation form again. And then once we get it in y equals the new equation, step 3 is just write it in the correct form. So to state that you found the inverse, instead of writing it as y, you'll write it as y inverse to state this is the inverse of y. So our third step is literally just write it correctly. So if you started out with f of x, your last step would be just to write f inverse of x. We found the inverse. All right, so let's do number 3 on the pink worksheet. Here we go. So we're just going to follow these step-by-step instructions. So given y is equal to 2x minus 3, we're going to find the inverse. So it's an equation. So we're going to follow these steps. To find the inverse, first switch x and y. So we're going to have x is equal to 2y minus 3. You see how I just switched x and y? Okay, we've done our first step. Second step is solve for y. Get y all by itself using correct algebra in the correct order. What should I do first? Add 3 to both sides of the equation. That is true. So over here we have x plus 3 equals 2y, correct? Next step to get y alone. Divide by 2, divide by 2. So we have y is equal to x plus 3 over 2. A lot of teachers let their students stop there, but I'm not going to have you stop there because here's why. If I said graph that, I know some of you would be like, I don't really know how. And this is the easiest thing ever. Guys, let's rewrite it in the prettier form. And on an ACT, you would never see that answer. Isn't this the same? Isn't this a line? Degree 1. So this is the same thing as this, right? 1/2 x, right? Pull out a 1/2. Plus, isn't 3 also divided by 2? Plus 3/2. Do you see how now we have written it correctly? Just better. Does that make sense, everybody? Nobody has questions? So write it in our third step is writing it in the correct notation. Okay, I'm going to scroll up. Give some people, okay. So this was our final answer for our inverse. Now our original function was y is equal to 2x minus 3. So if I graphed that, it would just be a reflection over y equals x. We don't need to graph it. It didn't ask us to. So I'm not going to graph it if you can answer this question for me. Is the inverse a function? Yes. Isn't a line a function? Yeah. So we're good, right? So we would just say yes. Does everybody see how this line, this is like started out as a line, ended up as a line? It's a line is a function, so we'd say yes. So my question for you is, think about a line, okay? What I want us to do is see if we can go this far. Domain of the original. So here's the original down here. Like, you don't need to write this down, but I just want you to look. What would the domain be? What is a line growing from left to right? This domain. Guys, what does a line look like? Okay, I'll graph it for you then. -3 up 2 over 1, and so on, right? What's my function doing from left to right? All real numbers, okay? So then what's my range on my inverse going to be? All real numbers, right? Okay, good. Good, because we know that this is domain's this range. So now let's look at this as domain, the inverses. Isn't this just a line again? So what would the domain be? So what's my range on a line? All real numbers. So that makes sense, right? Okay, perfect. Next problem, number 4. It says find the inverse. So our first step is switch x and y. Here we go. X is equal to 2. Why am I saying 2? Y plus 9 over 2. I switch x and y. Okay, now we're using algebra to get y alone. First step, tell me. Correct first step. We did switch x and y, so now we're doing, good, multiply both sides by 2. We got to do that first. 2's divide out. So we have 2x equals y plus 9. Next step to get y alone. Minus 9 from both sides. So we have y inverse is equal to 2x minus 9, right? Okay, everybody, you have my original function, which is this, which is not written very pretty, which is really just 1/2 x plus 9/2, right? Isn't it a line? I'm not going to graph it if we can see it without graphing it. What's the domain of a line? All real numbers. So what's my range of this? All real numbers. Okay, what's my range on, let's do it this way. What's my range on a line? All real numbers. So what's my domain going to be on my inverse? All real numbers. Okay, good. Okay, number 5 on the pink. Here we go. We're all doing it together, so you have less homework. Number 5. Switch x and y. So we have x is equal to 1/2 y minus 2. What's my first step? Add 2 to both sides. So we have x plus 2 equals 1/2 y, correct? Next step is to, that's one way of doing it, but that's making it the hardest way possible. Let's think a little bit, to make our life easier, what's another way of doing fixing that 1/2? Multiplying by 2. Let's always do it the smartest, easiest way. I don't want to have to divide by a fraction, so we're going to multiply both sides by 2. Now, is that just this x by 2 or the whole side? Good, we have to put parentheses. You said both sides by 2, so this side all has to be multiplied by 2. So we could leave it as 2, x plus 2 equals y. That is a correct, acceptable answer, or you could distribute it. So y is equal to 2x plus 4. What's the domain on my this is my inverse. What's the domain on my line? All real numbers, so what's the range on my original? And then my domain on my original function. All real numbers, so the range is all real numbers. Do you see how we just use it to help ourselves not have to think as hard? Anybody confused? All right, let's do this one that's not a linear one. Here we go. First step, switch x and y. X is equal to square root of x minus 2x minus 1. What am I writing? Y, right? Switch x and y. First step to get rid of to get y alone. Good, square both sides, right? So we have x squared is equal to 2y minus 1, because root cancel out with power. Next step to get y alone. Good, x squared plus 1 equals 2y. Next step. Are you guys all okay? Okay, divide by 2. Okay, and y is alone. Now understand, I would rather see this. Isn't this the same thing as 1/2 x squared plus a half? That's how I'd like to see it written, because then we know how to graph that, right? Isn't that a quadratic that's been shifted up a half? Okay, and then a stretch, a compression of a half. So see the benefits of writing it like this. Okay, so I want us to think about a couple things here. Isn't this a shift of right a half, guys? Now why? Because don't we have to fix the 2? So we pull out a 2. We have the square root of 2. Left is x minus 1 divided by 2 divided by 2. Guys, x minus a half. We spent like half the day learning this last time. Right? We did. Okay, so what's my shift? Right a half. Okay. Something that looks like this. There's no shift up or down on that, right? So I'm just starting a rough sketch to get you an idea of domain and range, okay? Then, okay, so what's my domain on this? Of my original, a half to infinity. So my domain of my original is 1/2 to infinity. And my range on my original is, no, range is y value. 0 to infinity. Are we all paying attention? Because this part's where it gets in depth. Some of you I can tell aren't. So our range is 0 to infinity. Okay, so then what's the domain of my inverse? Isn't the domain on my inverse the range on my original, guys? So you would say 0 to infinity. Scroll up. And then the range is going to be, this is domain, which makes sense, right? Now, why does that make sense? If I was going to graph the parabola, let me go back down. If I graph this parabola, it's up a half, right? Guys, shift up a half. And it looks like this. Now, look what happens. Uh-oh. Uh-oh. That's a full-on parabola. Was that a full parabola on its side? No, it wasn't only the positive half, the upper half. So, it was only that half, right? Look, picture our reflection. Okay, so this is our inverse for x values greater than 0. Greater than or equal to 0. Okay, so that's the honors level. We'd expect you to put that. And regular, I'm not worried about it, but I did want to talk about it because everybody sees. Okay, because it's not the full parabola. It's only for x values greater than 0, which makes sense to look at our domain. Does that make sense? Okay. Okay, next one, number 7, not so in depth. A little thinking though. Okay, so here we go. We switch x and y. X is equal to 4y squared minus 4. This is my last example that I'm going to let you just go for it. You're going to want to watch. So what do we do first? Add 4, right? So we have x plus 4 equals 4y squared. Let me show you what would be expected. Next step would be to, good, divide both sides by 4. So we have x plus 4 over 4 equals y squared. Next step, square root. Now, isn't this a full quadratic? Let me just graph it so we can picture it. Something like this. It doesn't need to be perfect. It's a full quadratic, the original, right? So when we take the square root of both sides of the equation, don't I need the top and bottom half of that? So plus and minus. Everybody see what I'm saying? Okay. We need the plus and minus square root, right? Everybody? This, we need the full on thing reflected. Does everybody see what I'm saying? So don't forget plus or minus. So now we have y inverse equals plus or minus the square root of x plus 4 over 4. Now in a regular level, this would be an acceptable answer. However, on honors or pre-calculus level, this is a non-acceptable answer. Here's why. So most of you want to push yourselves and go further. Okay, here's why. So watch. Isn't this, can't we split this up? So we really have plus or minus, and you should all pay attention to this because I really want you to push yourselves over the square root of 4. What is, does that simplify? No. Does that simplify? Okay, so we really have plus or minus the square root of x plus 4 over 2, which in pre-calculus, we would look at it as y inverse equals plus or minus, can't we pull that out and say it's 1/2 square root of x plus 4? Do you see how that's a lot prettier than that bad boy? Because that's just a shift from the parent function. Whereas if we would have stopped here, in regular, I'd say they'd get the idea. I'll probably give them most of the points. But if you were in honors, you'd mark that wrong. So push yourselves because you're going on to pre-calculus next year, and this is what's acceptable. Does that make sense, everybody? Okay, perfect. So my question for you is the inverse a function? No. Right? It was the top half of the quadratic. The original was a quadratic. And if we flip it on its side, it now becomes not a function. Remember that? So because we have plus and minus, it's not a function, right, everybody? Okay, so my question, I didn't even ask that on this one. Was this one's inverse a function? Yes, right? Still a function. Okay, good. Okay. I'm going to have you practice. Go to the white worksheet. Start practicing 5 through 16. I'm going to give you a second to start going. So you're just finding the inverse, and then is the inverse a function? Do not forget your plus or minuses. If you're taking a square root, if you start with a parabola, a full parabola, you need both the top and bottom half of the square root. Ready, set, go. Checking those with me. Okay. So I just want to go back to the pink worksheet and show you what would be an acceptable answer on something that doesn't come out nice and pretty. And then I'll show you what I would do if I was you, because you're going on to pre-calculus, and what would be acceptable in honors. So here we go. First step, I would be watching because they're not all going to come out pretty like we've seen. So watch. Number 8. First, we switch x and y. So we have x is equal to 2y squared plus 5. First step is subtract 5, right? I'm back to the pink. We should all be back to the pink doing this with me. Trust me, you want to. So we'll subtract 5 first. So we have x minus 5 equals 2y squared. Are we all following? Divide by 2, right? Okay. So we have x minus 5 over 2 equals y squared. Next step? Square root, square root. So root cancels out with power. So we have plus or minus x minus 5 over 2 equals y, right? Now this would be, I guess, an acceptable answer in regular, but in honors this would be considered wrong. We should split it up, right? So we would say y is equal to, we gotta be careful. So we have plus or minus the square root of x minus 5 over the square root of 2, right? Now problem, square root of 2 is a decimal, right? So we can't, no, you're right there. What's our next step? Luis, say it. We can't, that was right. We cannot have a square root in the bottom. So in honors, you would recognize I need to, yeah, use the correct lingo. Isn't that called rationalizing the denominator? Hey, are we all paying attention? Because I really will expect most of you to be able to do it this way. So what do we multiply by the square root of 2 over the square root of 2? So we have y is equal to plus and minus. It's the square root of 2 times all that stuff. So you would do the square root of 2 and x minus 5 in parentheses. Otherwise, we wouldn't be right? And then all over square root of 4, which is 2. Now, a final answer in pre-calculus or in honors would be 1/2 the square root of 2x minus 5. Does everybody see how I did that? It's a way prettier answer than that for the most part. You get what I'm saying? Yes. But it did take some thought. So how about you guys give one a try? The worst you could be is wrong. Are you ready to give one a try? Okay. So let me show you something how easy this is though. What's the domain? Hey, look at this original quadratic. What's my domain of the quadrant? Well, let's try it really quick. A rough sketch. Look, it looks like this. What's the domain of my original function? Good. All real numbers. So what's the range of this? All real numbers. What's the domain? What's the range of my original function? 5 to infinity? So what is my domain of my inverse? 5 to infinity. Now, does it make sense? Look, wasn't a shift of right 5? Right? So do you see how that does make sense? Okay. Cool. So what I want you to do is try number 12, because this is another one that doesn't come out pretty. See if you can go all the way to get it right to where a pre-calculus student would get it, simplification-wise. Ready, go. Number 12 on the pink.